Alright guys, welcome to 1.5, Solving Compound Inequalities. Today we're going to be following along by this video format. As you will notice, I am not in class today. I am on close contact quarantine, so it is unfortunate. It sucks, but this is the world we're living in right now, so we're going to get through it. We're going to get through it together. I will be back on Tuesday, so if you have questions that can wait until then, I will be back, so come see me during class or during one time. But if you have urgent questions, please send me a message on Canvas. I'll still be answering those. So if you do have a homework question or adult math question, just send me a screenshot, send it to me through Canvas, and I can help you work it out through there. But get out your notes packets. We're going to be following along with 1.5 today. Please make sure that you are taking good notes and you're not sleeping or not paying attention. To get started here, I'm going to have the video pause, please. Go ahead and fill out these blanks. They shouldn't be too hard since we, hint, maybe did them in 1.4. But go ahead and fill out these blanks and then do examples 1 and 2 as your warm-up. Okay, so first up, what is an inequality? Again, it is anything that contains the following four symbols. We talked about what these are. The first one is greater than. Second one, less than. Third one, greater than or equal to. And fourth one, less than or equal to. Hopefully you got all those. Then we have the types of dots that they include. The first two are open dots, right? They're not equal to, so they don't have shading. The next two are equal to, so they do have shading. Think extra line equals extra shading. So these are going to be closed dots. Okay, hopefully you got those. We then have our rules. These are the same rules as last time. Okay, if the variable is being eaten, you graph to the right. If it is not being eaten, if it's being pointed at, then you're going to graph to the left. Think less than left again, but the variables have to be on the left for it to work that way. So looking at the first one, my variable is on the left. This is the way I prefer to write it. Is it being eaten or is it not? It is definitely not, right? So I can put a dot on 6. It's going to be an open dot because this is not less than or equal to, it's just less than. And it's being pointed at, which means go left, less than left. Okay? The next one, -4 is less than or equal to y. I'm going to write it the preferred pretty way. Looks just like this. Okay, that's the same exact equation because y is still being eaten either way. Okay, but I just wrote it a better way. And now I can graph that, put -4 in the middle. So it's going to be an open or closed dot. It's going to be closed because it is greater than or equal to. And it's greater than, so that variable is being eaten. We are going to the right. Okay, moving right along. Alright, now we've got this table to fill out over compound inequalities. What are compound inequalities? So what these are inequalities that place two inequalities together by and or. By and or. And we're going to talk about what these two things mean. So an and function. What this is it's going to be an intersection. An intersection of two functions. Okay? What it's going to look like. Normally, the functions are written as one. Or written together, I guess we should say. When it is graphed, it's going to look like a line segment. And how that's going to look is something like this. Closed dot to closed dot, open dot to open dot. It could be a closed dot to an open dot, or an open dot to a closed dot. We then have OR functions. These are what we call unions, okay? Not an onion, but a union. Hopefully you've heard that word before. These are going to be written separately, usually containing the word OR. So usually it's just going to tell us that it's an OR function. Okay? These are going to be graphed as gaps. Okay, so normally it's going to look something like this. Got one arrow going one way and another arrow going the other way. These can be any kind of dot, okay, open or closed. So we could have one of each, or two of the same. Okay. We will keep going on this, so make sure you've got this table filled in. Okay. Okay. Example 1 is to solve and graph. So we'll just start off looking at this one. Do we think this is an AND or an OR function? Is it written together or is it written separately, usually with the word OR? It's written as one, right? It is. So, to solve an AND function, what we need to do is we need to split this into two separate problems, okay? The first problem is just going to be this right here. So -6 is less than 2x minus 4. So I'm going to write that over here to the side. That is my first problem. My second problem is going to be 2x minus 4 is less than 12. Okay, the reason I split it up that way, and make sure you pay attention to this. This problem is everything in front of the first inequality symbol, so that -6, and then it's everything leading up to the next one. So we cut it off right there. Same thing for the second problem. It's everything after that next inequality symbol. Okay, and then the symbol and everything after that. So a big error that we see with these types of problems is that a lot of students want to just divide the problem like this. Now, can those be my two problems? No, they cannot. You cannot split it down the middle like that, okay? Do not split it down the middle. Make sure you include the whole middle part in both problems, okay? Just as we did over here. So, once we have it split, then we're good to go. We're good to just solve these. So, we'll solve them just like normal, as we did last class. So, the first step is just to add that 4 over, just like if it was an equation, okay? When we do that, these cancel. -6 plus 4 is just going to be -2 is less than 2x. And now, again, we're still getting x by itself, so now we need to divide by that 2. It's a +2, so I don't have to flip the sign. -2 divided by 2 is just going to be a -1 is less than x. So there's my first answer. If I wanted to write it a better way, it's the same thing as x is greater than -1, because again, x is being eaten right here, and if I flip it, it's still being eaten, and it's still the same variable and the same number. The next one, solve it very similar. Add 4 on both sides. 2x is less than 16. We then want to divide by 2. And we get x is less than 16 divided by 2, which is 8. So I now have these two problems. Now I just need to graph them on the same number line. Okay, so not separately, but together. So to put them in order, what comes first, -1 or 8? Hopefully you said -1. It is less. We then want to look at what kind of dots we have. So on -1, we've got an open dot. On 8, we also have open dot. Okay. So x is greater than -1, which means for -1, we're going to start shading to the right. X is less than 8, so we're going to start shading to the left. Well, since this is an AND function, we just want to know what they have in common. So it's just this line right here. And you're welcome to do your shading up here above. So like for instance, I could have just started shading here left, here right, and then saw what they had in common and then brought it down to graph it. But you're welcome to do it all right there. And if you mess up, just erase. So this is an AND function. We said an AND function is supposed to look like a line segment. Does this look like a line segment? It does, even though it's kind of an ugly one. Sorry, I'm not the best artist. This is good. So we are good to go. This one's an example of an AND function. Okay, so make sure you have this one down. We're going to move right along. Okay, starting off on this one. First off, let's fix Ms. Browning's typo. So this first one should be 4y minus 2 is greater than 2. We forgot to put that 2 in there. So it should just say 4y minus 2 is greater than 2, or 3y minus 4 is less than or equal to -13. Okay, is this an AND or an OR function? First off. Well, it tells us, right? It's an OR function. And if we know our characteristics of an OR function, we know, first off, they're written separately, normally, right? It tells us that they're an OR function. And then we know that whenever we graph it, it's going to, hopefully, look like a gap. Okay, so let's make sure that we keep that in mind as we're graphing these, because if we get down to it and we end up with a line segment or something that looks wonky, then that probably means we did something wrong. Okay, so just keep that in mind. A good little guess and check method. But let's keep going with this. So we're just going to solve these as normal. So the first one, we're just going to add 2. 4y is greater than 2 plus 2, which is 4. Should all know that. Last step is just to divide by 4 on each side, and we end up with y is greater than 1. Okay. Next one. Solve this same problem, so same process here. Add 4 on each side. -13 plus 4 is going to be -9. And then we're going to divide by 3, divide by 3. It's a +3, so we don't have to worry about flipping anything, but we end up with y is less than or equal to -3, because -9 divided by 3 is -3. Okay. We now have 2 answers, which is good. We just need to graph them. Which one comes first, -3 or 1? Hopefully you said -3. Does -3 have an open or a closed dot? It should be closed because it is less than or equal to. What about 1? That one's going to be open because it is just greater than. Okay, so we'll start with the -3. It says y is less than or equal to -3. So less than, am I shading left or right? Left. And y is greater than 1. So is that right or left? Right. Okay. Does this look like an OR function? I think so. We've got a big, nice gap here in the middle, okay? And that's what we know we're supposed to have. We solved these correctly, okay? We could go back if we wanted to and plug in these numbers and make sure that they worked in our original. So like plug in 1 for y if we wanted to. But we don't have to do that. We can just go ahead and move on because we know this is what an OR function looks like. Okay, now we're getting into example 3 here. So a little more complex of an equation, but we can do it. We're pros at this, right? Hopefully you're nodding your head. So solve and graph these. Is this an AND or an OR? Okay, so these are written separately, but, look at the word between them. It does say AND. Okay, so this is going to be an and function. They're not trying to trick us by any means here. If they say it's an and function, it is. Okay, so we'll go ahead and try this one. So we'll solve both sides. The first one, first step, add 7. We end up with 4x is less than 9 plus 7, which is 16. Then do what on both sides? Divide. X is less than 4. It's going to be your answer. Okay, moving right along to the next one. Subtract 7 on both sides. 5x is greater than or equal to 3 minus 7, which is going to be -4. And then we want to divide by 5, and we end up with x is greater than or equal to -4/5. Leave it as a fraction. I mean, you can give me a decimal, okay, but I don't really need one. The fraction works just fine. To put these on a number line, obviously the negative number is going to be less than the positive number. Looks like the -4/5 has a closed circle dot because it's greater than or equal to. The less than has a open dot. Less than 4 means I'm shading to the left here. Greater than or equal to -4/5 means I'm shading to the right, which means this is going to be a line segment. Did I want it to be a line segment? Yes, I did. Because it's an and, which means the two things, what they both have in common. Kind of like if I sent you to the grocery store, okay? And I said, I need a Snickers bar and a Twix bar, okay? So what I need from you is both. That's what an and function is. So here for -4/5 and 4, we are just going to put on this graph what they both have in common, because I know that x is greater than or equal to -4/5. So I know this line actually goes all the way to the left here. Okay, and same thing for less than 4. I know that this line actually goes all the way to the left. Okay, so how this works, again, is we're just wanting what they both have, which is why only this line segment is drawn. We don't need to draw -infinity all the way to infinity, because that's not what it's asking for. It's asking what do both of these have in common. And then whenever we get to OR functions, we have that gap because it's asking what do these not have in common, okay? It doesn't want to know what they both have. It wants to know what does one have that the other doesn't, which is why you have a gap in between the two and then two lines going in separate directions. Okay, example 4. Go ahead and try this one on your own. So pause the video here. Try this one. It's nothing that is too scary. You shouldn't get anything crazy on this. Okay, so hopefully what you did here was you split this into two problems. The first problem being this right here. So -4 is less than or equal to 3x minus 7. And then the next problem, everything after that first inequality to the end. So 3x minus 7 is less than 8. And then hopefully you just solve these. Pretend that like they're equations, right? They don't work any different. Add 7 on both sides. We end up with 3 is less than or equal to 3x. Divide by 3. And we end up with 3 divided by 3 equaling 1. The prettier form of that would just be 8x is greater than or equal to 1. You can leave it like this. It doesn't matter, okay? But just know that the second part, it's easier to read, easier to graph, exact same thing, okay? But if you prefer to write it at the top and you're able to graph it the correct way because you see that x is being eaten here, totally fine. Leave it then. It doesn't matter to me. Okay, next one. Add 7 on both sides. We end up with 3x is less than 15. Divide by 3, divide by 3. X is less than 5. Okay, put them on a number line now. 1 comes before 5. The 1 has a closed circle. The 5 has an open circle. X is greater than 1, which means I'm shading this direction. X is less than 5, shading this direction. These meet in a line segment. Did I want them to meet in a line segment? Was this an and or an or? And. Are ands line segments? Yes. Yes, yes, yes. They should be. So this one is good. It checks out. Example 5. Try this or function on your own. So pause here. You can do it. Okay, hopefully you got this one. Subtract 1 on each side. We get negative 2x is less than or equal to negative 4. Divide by negative 2. Ooh, hopefully you saw what I'm seeing. When I divide by a negative, flip that sign. Negative 4 divided by negative 2 is a positive 2. Okay, come on over to the left side. Subtract that 7 off. Get negative 3 over here. 3x on this side. Divide by 3. It's a positive 3, so don't change the sign on that one. Negative 3 divided by 3 is 1. Okay, so hopefully you got these two answers. I hope that first part didn't trip you up on the flipping the sign, but remember, dividing by a negative, gotta flip the sign. Now time just to plot these on our number line. Negative 1 and 2. Looks like we got 2 closed dots, makes it easy. X is greater than or equal to 2. X is less than or equal to negative 1. And it's an or function. I have a gap. I'm good. Okay. Try this one. Pause here. Okay. We'll go ahead and solve. Negative 5x is less than or equal to negative 5. Divide by negative 5. Ooh, ooh, ooh. Dividing by a negative. Flip, flip, flip. X is greater than or equal to 1. Come on back up here. 2x is less than or equal to 3 minus 5, which is just going to be a negative 2. Divide by 2. It's a positive 2 that we're dividing by, so don't worry about flipping. And now this is what I have. Okay, so we'll notice we've got negative 1 and 1. What do we notice about their dots? They are closed. X is greater than or equal to 1. X is less than or equal to negative 1. This was an and or an or. Or. So, looks like we're good to go. Last one more problem. Example 7. Okay. Think about what the first thing we would do on this one is. I'll just give you a couple seconds. What would we do first on this one? Don't freak out. Fractions won't kill us, but we can kill them, right? That's how this works. So, this is an and or an or. It's an or function. They're written separately. Okay, so I know what this is supposed to look like. So keep that in mind as you're solving it. I know what the end goal is. Now I've just got to get there. So the first thing here, I know I have fractions, but these are actually two separate problems. So if your first instinct was to multiply everything by 12, you could, okay? Or I could just see that these are two separate problems. So the first problem, the only denominator I have is 3. So I'm just going to use 3 on both sides here. So multiply by 3 on this side, and multiply by 3 on this side. Again, if you picked 12, that's fine. You're just going to end up with a little bit bigger numbers, and that's okay. It's just going to give you bigger numbers, but they'll still give you the same answer as long as you do it right. 3 times 2/3. So 3 times 2 is 6. Divided by 3 is 2x. 3 times -4. Keep my sign. 3 times 3. And now I have that problem. Okay. Let's go ahead and just kill the fraction on the other side. Think about this. What number would you multiply by on this side? What would you do? Okay, so hopefully you said 4, because that is our only denominator. And if you remember back to our last little lesson, I could go ahead and distribute out this 1/4 x before I multiply by the 4, before I distribute out that 4. But I can also just use that little trick we said. If we haven't distributed yet, we can just multiply these front numbers. So 4 times 1/4, which was 4 times 1 is 4, divided by 4 is 1, right? So 1 times x plus 8, which is just x plus 8, would be what it gave us, is greater than 4 times -1. Okay, if you didn't do that though, so if you went ahead and distributed out the 1/4 here, so you get 1/4 x plus 1/4 times 8, which 1 times 8 is 8, divided by 4 is 2. And then you killed the fraction with the 4. So you just have to distribute twice. Just a little more work. Still going to get you the same answer. 4 times 1/4 is just 1x. 4 times 2 is a plus 8. Okay, so you see I got the same thing. Either way you go about it, doesn't matter. Okay, because again, as long as I'm getting the right answer, I don't care how you got there. There are a lot of ways. So in some math, there's a couple different ways to do things. So if you have a preferred way that's going to get you the right answer every time, go for it. Now we're just going to solve these. 2x is less than or equal to 9 plus 12, which is going to be 21. Divide by 2, divide by 2. We end up with x is less than or equal to 21/2. I'm just going to leave it like that. 21's not an even number. You could have gave me a decimal, that's fine too. 10.5, right? Next one, subtract 8 on both sides. X is greater than or equal to -12. Okay, which one is going to be first? Obviously the negative, right? And we'll have the 10/2, or 10.5, or 21/2. And I'm going to write this just over here to the side so I can erase it over here by a number line because it's bothering me. Okay, so now I've got my number line. I need what kind of dot on -12? Looks like a closed one. What kind of dot on 21/2? Also closed. X is less than or equal to 21/2, which means that I would be shading to the left on this one. Okay. Same thing with x is greater than or equal to -12. I'd be shading to the right. Well, if you notice, the reason I'm shading past here, this is an OR function. And what it would look like if I were to just stop at those dots like an AND function, is an AND function I would just have what they have in common here in the middle. But this is an OR function, so I'm going to keep going on both sides because it wants to know what they have apart too, right? Or just in general. So what it looks like here is that my whole number line is shaded. What did it mean when the whole number line was shaded back in the last chapter? And if you remember, it meant all real numbers. So that is what this one's going to be. This is one of those tricky ones, okay? Normally, if you get down to it and you have a whole number line shaded and it was supposed to be an OR function, I would recommend going back and checking your work just because it might mean that you did something wrong, especially if it's like the first or second one on the test or quiz or whatever. But just make sure you're checking. There are, though, some cases where it does end up shading the whole number line, which would be all real numbers. But just remember, compound functions are two functions together. AND functions are what they both have. OR functions are what they both have that the other doesn't. Okay, so or functions separate and functions written together normally. If you've got questions on those, let me know, but make sure you do the Delta Math assignment. When you get that done, work on the homework. You already have it, okay, so it shouldn't be anything crazy. But again, send me any message with any questions that you have, and good luck. Thank you. Bye.